So we've talked about interactivity and why it might be useful, either animation as an encoding or animation as a transition. We've talked about some other ways that you can use interactivity to enhance your data products, especially data visualizations. And then the question is, how do you actually make something interactive? So we've seen a lot of interactive graphics in this class. A lot of the ones that we've seen have been made using d3.js. So this is a JavaScript library for doing data visualization, essentially, but it's a very generic JavaScript library. It's essentially a way to map data to elements of the DOM, and it's pretty tricky to get the hang of. At least that's been my experience. It was developed by a man named Mike Bostock when he was at the New York Times. So if you see a visualization like this one, this is an interactive graphic. So when you hover over a state, then you can see some information about what's going on in that state. If you hover over some of these dots, you can see the brushing and linking like we've talked about before that's happening, where if you highlight Maryland, then you're also seeing Maryland on the map, and the same thing in all of these bubble plots. This is one of the ways that people do data visualization in an interactive way, is using d3.js. So if you wanted to see the source code for something like this, any browser that you're working with will allow you to view the source. You usually go up to some type of view menu. Sometimes there's a developer tools option, and then you can say view source, and it'll show you the HTML code that has generated the web page. And especially with the older versions of things made with D3, like this was made in 2014, you can just see all of the code that's used to make the visualization just directly in the HTML page. You've got things like d3.selectAll, categories.filter, statecats.population, and sort of JavaScript code like this that's using the syntax that might be familiar to you if you are someone who's done web development. This is a data visualization that I made using D3. And this was something that I did in graduate school for a information design course. I was interested in looking at the relationship between a bunch of skirts in my wardrobe. So I took photographs of all the different skirts that I owned, and I created this sort of interactive web graphic that showed you things. And you could either have the dots in some kind of grouped fashion, you could group by the length of the skirt or the brand or the size, something like that, and you could filter by just the ones that have pockets, things like that. This is probably the most detailed D3 graphic that I've ever made, and the way that I did it is the way that many people who work with D3 do things like this, which is that I looked at existing D3 graphics that were already out there. So while there are some visualization libraries that you can just start with a blank page and then start writing some code. I think ggplot2 is one of those places where you can get yourself a pretty nice graphic pretty quickly. I don't think that anyone other than maybe Mike himself is writing D3 code just from scratch. Most people are looking at an example that already exists, and then they're editing the code to make it look the way that they want to. Since the development of D3, Mike has released this thing called Observable, which is a way to work with D3 code live in the web browser, and that's made it a lot easier to learn D3. So if that's something that you want to do, I'd really recommend checking out Observable. So for example, if you wanted to make a bar chart race, you could click in and see this data visualization, which is a bar chart that is updating over time and showing you which of these categories is winning. You can scroll down and you can see all of the code, and then you can click in the margin to edit things. So if you want to learn D3, again, I think that the way to do it is to start with an existing graphic and then modify it to update the data to be your data, rather than just trying to start with a totally blank page. Another tool that a lot of people use when they're doing data visualizations, which we didn't end up talking about in this class, is called Tableau. And Tableau is enterprise software. It can be really expensive. I probably could have gotten student licenses for you folks for this semester, but it just seemed like too much to add. And it's a way to do data visualization that works really well with data that you have locally on your computer, or it can hook up to huge databases. So it gets used by a lot of big companies to do data visualization. It has something called a visualization query language, VQL, on the back end. So it's keeping track of the operations that you're doing in your data visualization. I'm not sure if I said D3 is an implementation of The Grammar of Graphics by Leland Wilkinson. Tableau is another implementation of The Grammar of Graphics, and of course ggplot2 is an implementation of The Grammar of Graphics. So these are all founded on those principles of the way that you should be able to build up graphics from component pieces. So here's an example of a graphic that was made with Tableau. This is from La Nación, and it is an article about corruption in football, soccer, essentially. And so this interactive graphic, again, which has, tooltips and interactive elements. This was made using Tableau. I don't know that it actually says that it was made using Tableau, but this was something that I got off of the Tableau website. It was sort of showing some nice examples of Tableau graphics. And so one of the things that's really nice about Tableau is it allows people who are using it to just embed the visualization right into a website. And so a lot of journalists use it because it's a quick way to make an interactive graphic, and then they can just embed it right into their story. Like this interactive graphic has been embedded into this story. Another system that people use when they're making interactive graphics is called Plotly, and Plotly is a company that does a bunch of different things. One thing that they do is they have an interactive web application where you can build interactive graphics. So that's Dash. And then they also have these libraries that allow you to make interactive graphics in a bunch of different languages like Python and R and Julia. So they have a gallery of a bunch of demo apps if you want to look at them, and there are many ways that you could have created a graph like this. You could have used, some Python or R code, or you could have developed it right in the interactive online system. Another system that you could use to make interactive graphics is Shiny. So Shiny is an R package, and it essentially lets you make JavaScript graphics, but without having to know any JavaScript. So if you are someone who is an R expert, which many of you are, it can be easier to learn how to make something interactive in Shiny rather than working in JavaScript directly. And Shiny is really powerful because it can make interactive graphics, and it can also make these dashboards. So if you go and look at the Shiny gallery, there are many examples of these sorts of tools that people might create. I think one of the places where Shiny really shines is in making dashboards that can be used internally within companies. So I know there are lots of companies that do things like this. Airbnb is one company that comes to mind. So if they have some internal data and they want to be able to track it over time, then their analyst could make an app using Shiny, like a dashboard, and then executives could go check that dashboard and see what was going on in real time. You might have seen there's this famous example on the New York Times. It's the Dialect Survey. So it asks you questions about, what do you call the bug that lights up at nighttime? Is that a firefly or a lightning bug? What do you call a sweetened carbonated beverage? Is it pop or soda or Coke? And then it will tell you where it thinks that you are from. So I couldn't actually find the old Shiny app, but Josh Katz, who's the one who made that data product, he initially made it as a Shiny app. And so it was hosted on shinyapps.io, which is an RStudio service. I have a shinyapps.io account that I pay like $10 a month on so that I can have a certain number of users who can go look at my apps. And so he was doing a similar thing. But the demand for using that Shiny app far past the amount that he was paying for. And so they had to translate it into a more robust web application. So if you go look at the Dialect Survey map now, I think that it's done in pure JavaScript on the New York Times website, and it's not using Shiny, which would require an R server on the back end, and it would be spinning it up and loading all of the R packages. So there are a lot of things that can make Shiny kind of a slow and heavy way to do interactive graphics. It's nice if you are just going to have a few users, but if you're going to have a lot of users, it's maybe not the right option. And so one illustration of this, I saw Ben Welsh, who works at the LA Times, was tweeting that LA County built the most important page it was ever going to make in a Shiny app. And then he said, here's how that's going. And he's got a screenshot of an error has occurred. And of course, you can see it's, attaching these packages. And, this package is masking this thing, and this is masking this other thing. And so LA County made a Shiny app because obviously their analysts are using R. And so they thought, well, we'll just make a Shiny app, but they didn't realize how much traffic they were going to get to their COVID-19 tracking app. I was able to get the app to load. It does take a while, and sometimes the plots are just sort of like empty spaces, but you can get it to load. But they might be thinking about redoing this in something like pure JavaScript or in D3.js, something that doesn't require as much on the back end. And the other thing that I noticed when I went and looked at this dashboard is that this is using Plotly graphics within the Shiny dashboard. So I haven't talked specifically about how you could make a Plotly graphic, but I can recognize it from the stuff that's sort of showing at the top of this graphic. I recognize those user interface controls as being things that come with Plotly graphics. So this isn't just a standard ggplot2 graphic that's been embedded into a Shiny app. This is a Plotly graphic that's been embedded into a Shiny app. So you can sort of put some of these pieces together. Like you could put D3 graphics within Shiny apps, or you could embed a Plotly graphic in a Shiny app. There's lots of options. So it's not just like you have to pick one of these things. You can mix and match of them, but it kind of depends on if you want to write pure JavaScript or if you want to stick with something that you're maybe more familiar with, like R. So I had you folks look at the first 2 chapters of the Plotly book by Carson Sievert. So the preface is just kind of like explaining why you would want interactive web graphics from R, some of the power of that. And then chapter 2 is giving you kind of an overview of Plotly as a function from the Plotly R package, and then the function ggplotly. So if this is hooking up to a JavaScript library on the backend, plotly.js, and plot_ly, that R function, is making a direct interface. So again, this isn't an implementation of the grammar of graphics like ggplot2, but it's another way to write it. And the syntax looks different for a Plotly graphic. So instead of doing like ggplot parentheses diamonds plus geom bar, AES, it's doing things like x equal and then a tilde. So this is an R formula. I'm not sure if we've talked about those in this class. Tilde cut, color equals tilde clarity, etc. But then you could make a ggplot-like graphic that's actually a Plotly graphic using R code. So this would run inside your RStudio. And I think if you want to make something directly in Plotly, it makes sense to learn this syntax. But for me, I think that usually the ggplotly function is kind of all I need. So the ggplotly function is just a way that takes something that you've made already in ggplot2 and it turns it into a Plotly object. It just adds interactivity automatically. You don't get as much control as you would if you built up the graphic yourself, but it's kind of what you're going to need just to get started. So I'm just going to show you how to do that on a simple graphic. All right, we have our packages that we've used quite a bit in this class before. We've got the Tidyverse package and the 538 package. You would need one more package in order to do Plotly graphics, and it's called Plotly. So if you don't have that already, you might need to install .packages, parentheses, in quotes, Plotly. I'm not going to run that right now because I already have it installed. I don't remember if I installed it on RStudio Cloud for you or not, but it's pretty quick to install. And then you would library Plotly to get the access to that package and its functions. So I'm just going to run, I think I'd shown you this example before when we were doing the copy the masters. So I'm taking this chess transfers data from the 538 package, and I guess we could just look at it, chess transfers So this had the information about the people and where they got transferred, and I am grouping it by the federation, summarizing how many people were transferred by federation, arranging in descending order of total, taking the top 10, slicing them off, and then making my federation variable an ordered factor in order of the total. So if I control enter here, now I've got chess data, just has 10 observations. It's got each federation and then the total. And I could make a pretty simple ggplot. ggplot chess data plus geom_bar, where my aesthetics, my x is federation, my y is total, my stat is identity, because I don't want the geom_bar to be doing the counting for me. And then I'm gonna coord flip so that I can get it the sideways way that I'd like it. So that's sort of the beginning of a graphic that is a copy to masters. So this is a static ggplot2 graph. It shows up in my plots tab over here in this window. And then what I'm going to do is I'm going to give this a name like P1, control enter. And then if I wanted to, I could just, make that one show up again by doing P1 and executing that. Or I can ggplotly of P1. And when I do this, now I'm going to get a graphic. It's showing up in the Viewer tab, not in the Plots tab, and it looks very similar. It looks like maybe the margins have changed a little bit, and that's because Plotly is going to put some controls around that graphic. And so if I, come here, I can see there's these same controls that I was saying I could see in that Shiny app that LA County produced. And if I hover over a bar, it tells me what the federation is and what the total is. So it's just showing me by default anything that I've put into the aesthetics, I can see that information in the tooltip. But I could make that more specific if I wanted to get into it. And then if I knit my document, should get an HTML document. So this first one, this is just P1. This is the static ggplot2 graph. But then down here, I have my ggplotly, and this is the interactive graphic, which is embedded right in my HTML file. I could email this to my boss, and they could, zoom in if they wanted to. They could, do the hover overs and things like this. And I know a lot of folks who work in industry have found that the ggplotly is super helpful. It's almost all you need. And if you come in with an interactive graphic like this to a meeting and your boss says, well, but I just want to look at, a specific section of this, and you can, zoom in and highlight it. This is maybe not the most exciting example, but then that really impresses people. So that's one of the ways that you can do interactivity in R. So my recommendation would be, if you want to make an interactive graphic and you already know R, I would start with the Plotly package, maybe start with ggplotly. You could move on to making Plotly graphics using the Plotly syntax with those, formulas, equals, tilde, whatever the variable is. And then if you want to do something more advanced, you could use Shiny. There's some really good tutorial videos already out there about Shiny. Shiny can be more complicated because it has these two pieces. It has the server and the UI, and those two pieces need to be really well synced together. I sort of believe that there's going to be a little bit more enhancement in the user interface for Shiny eventually. It's been developing over the years that it's getting more user-friendly, but it's still kind of hard conceptually to hold those two things in your mind at once. And if you want to really go further and you want to do something super custom that isn't possible using the standard plot options that you have in ggplot2, you might want to think about learning d3.js, or you can always do the same things that you do in d3 in pure JavaScript. It is easier to do them in d3. But that's kind of what I would think of as the trajectory of interactivity. And I guess the last thing I'll say is people who are programmers like to make fun of Excel, because Excel is not a reproducible way to do data analysis. If you do something for 1 year and then your boss says, well, I want you to do the same thing, but for the next year, you have to repeat all of the same operations in the spreadsheet in a way that you wouldn't have to in R. And I know lots of people who do sort of automatically updating quarterly reports in R Markdown documents and maybe even Shiny dashboards. And that kind of, just update the data and then rerun the whole analysis, that's not possible in Excel. But one of the things that is possible in Excel are responsive graphics. So if you change the data in your Excel spreadsheet, then you're going to see an an instant change in all of the formulas that depend on those cells and all of the graphics that depend on them. And so that's something that you can get in R by using Plotly or Shiny, something like that. You can get it in JavaScript, but it takes a lot of work. And so I think interactivity and interactive graphics, that's one of the places where I think we need to not make fun of Excel as much as our initial impulse would be to do.